on this computer. Okay, and I'll share this with you. Yeah, I'll share the recording with you when it's done.
Okay.
Okay, so the way, and again, everybody, so the other thing is everybody sort of processes information differently. I'm just going to sort of walk you through how I would take these requirements that we've got here and sort of begin to think about actually writing code. Now with this, and even you know where you're at, and even where I'm at now, like I'm not going to look at this and just start hacking out code inside the IDE. I'm gonna, you know, in this case, since we're working from the Mirac book, I would go to chapter 8 and sort of look at the examples there and use that as a template for what I would do. Or even better, probably what I would do is look at some of the book examples, the code that comes with the book, and I'd probably be doing a lot of copy and pasting from those, just so you know that just sort of takes the syntax out of it. You don't have to worry about fat fingering something, but you know, just from actual like writing code standpoint, that's the way I would do it. But let's just sort of read through these requirements here, and I'll sort of tell you what I'm thinking. And feel free to just jump in anytime if you have questions. So in this case, we've got an area calculator. So obviously this is going to calculate the area of something. Now we see here that we've got various objects that we're going to be calculating the area for. Now, the first thing that brings up in my mind, again, if I was approaching this from a standpoint of a problem solving standpoint, I would probably Google how to calculate area for, in this case, squares. Looks like based on the console example they've got, we're going to be this is going to calculate the area of circles, squares, or rectangles. So, and I don't know, let's see if the requirements give you the math. So yeah, it actually gives you the math here. So we don't need, and I'm just looking.
Well, I think I'm missing
section here.
oh no, I have it. I thought I was missing a page, but no, I've got it.
Yeah. So it tells you the math that we're going to use. Now it doesn't, you know, we're going to have to make some inferences as far as this squaring goes here. But anyway, we can that sort of takes care of that for us. So we've got a console example here, so we know what the interaction with the user is going to look like as far as getting data from the user, what the prompts are. Most of that should be straightforward. Obviously, we'll be using probably a scanner, you know, based on what we've done in the past in the Mirac book. We'll be using a scanner object just to get information back from the user. So that's that sort of speaks for itself. So let's look at the specs, and here's where it sort of gets into the meat of what the classes are and what we want them to look like. So and I'm just going to sort of read through these, and we can chat about them. Create an abstract class named shape. This class should contain an abstract method named getArea, and that returns a double type. Now, I think I sort of used this model in the, or I talked about this in the screencast I did for this chapter, of the way I like to think about classes are, and even with inheritance too, is that they're sort of representations of real things in life. And I think I used the animal example in the screencast, where you've got mammal up top would be a parent class, and then you might have dog or human as child classes. So that's sort of the model they're doing here, right? You've got this bigger umbrella of shape that they're calling shape. That's going to be the parent class. And then obviously circle, rectangles, and let's see, circle, square, and rectangle are all shapes. So they're going to be child classes that are going to inherit from that parent class of shape. And that makes sense, right?
Right, of course.
Yeah, and I mean, again, this is something you see a lot in software development in general. You're trying to categorize things, and so this is just a way to sort of put things in boxes, but also be able to reuse code too. So right. You know,
we went over a lot of the OOP stuff in PHP, and so I kind of get that understanding from the classes, and then inheritance and the child class, parent class kind of thing. The thing that I've come across with, and you said a while back that you will be able to see, even if it's different programming languages, you can see the similarities between each of them. And I've seen a lot of that this semester with Java.
Good.
The thing that I'm having a trouble with is working with the different, so say like you're in the console or you're in the main app file, pulling from different classes. And I think you use the dot operator, so it would be class name dot operator, and then the method that you're working with that's correct, right?
Right. Mhm.
That's
It
what
is.
I was-
And that's general, and that's pretty general across the board, regardless of the language you're using too. I mean, generally that is what object-oriented programming is now. The implementations are somewhat different across languages. When I say implementations, I just mean the actual syntax and code you write is going to be a little different the way you call those. But as far as calling classes and methods, as you said, generally you're going to instantiate an object. You almost always use the new, you'll use the new keyword there, and that's going to create a new object. And then you can use that, you can use the convention of the object that you created dot, and then whatever method that you want to call on that class. And again, that's sort of general across all programming languages.
Okay.
Okay.
Okay. I had a question about that. I think that you just answered it. I was yesterday or day before. My question is, why would you create a new instance of the class to work with the class properties and methods when you can just call the properties and methods from the class itself?
Great question. So we have, and so let's see, have we talked about, I'm trying to think because I specifically cover that in one of the chapters. I'll have to go back and look, but we have what's called class methods versus instance methods.
Okay.
Instance methods are ones where you need to create a new object to be able to call that, method. Class methods, you don't have to create a new object. So just trying to think of a quick example here. We might, I don't want to try and come up with an example right off the top of my head, but I need to go back and look, because I feel like specifically I cover that in, I guess we haven't covered it yet, but anyway, again, to your question, there's class methods versus instance methods. Class methods, you don't have to instantiate an object to be able to call that. And in fact, yeah, an example, we've done the, if you recall, in the AB Tech app, if you recall there, I think you could do get school banner maybe, and that was an example. Let me see how quickly I could pull that up, because that would actually be a good example to look at. Wow. Example solutions, that was chapter 7. No. Modified exercises. Well, that's in the AB Tech app here. Here's our car. Well, you know what, I think there's an example in the dealership class. So get company banner, if you recall that one. Get company banner can be called, we could call that just by, in fact, let's leave that up and let me see if our solution actually shows that. Okay, well, get years in business is an example of one, right? So here we're calling this dealership get years in business, and get years in business is here. So this is an example of one where we didn't instantiate a new dealership object, right? All we did was call, and if you notice back over here, all we did was call the class name, and then we just called that method, and that in this case, in fact, we did it with this company email here too. All it's going to do is return, in this case, we're calling calendar.get instance. Basically, it's just going to return this current year minus a year started. So that's an example of, we would call that a class method. We didn't have to instantiate an object before we called that. And let's see if we can find an example of one where we instantiated an object.
And dealership, was dealership the parent?
Right. So, well, now in this case, we're not really, it's not a parent-child relationship. I mean, we're not, but it's going to work it's going to work the same way, whether it's whether we're talking about inheritance or it's just, it's just a class. So an example of a instance method is with this car. If you recall, we created this car 1, car 2, car 3. So in this case, we're actually using the new keyword. And so, yeah, car is an example. And let's see, these are all instance methods here. There's not an example of a class level method inside there. But anyway, in this case, we're having to actually call things like set VIN, make model, set dealer cost, things like that are instance methods. They're instance methods because you have to actually create an instance of that object first, and then you're able to call that method on the instance of that class or that object that you've created.
Okay.
Yeah, I wish I had the AB Tech example. I don't know why I'm not seeing that. It's hiding from me. Chapter 7, yeah, because I think we do both. I mean, the reason I'm thinking about that is I think I've got an example of class methods as well as instance methods inside, and maybe not. We created a student inside there too, and I can't remember if we had a student class. Maybe the instance methods were on the student class, not on the AB Tech class, but that's an example of, again, you don't need to instantiate. I think your question was, why do I need to instantiate an object to call a method? Why can't I just call the method from the class? And the answer is it depends. You can do both depending on if it's a class method or an instance method.
Okay.
Okay. Okay. So let's continue talking through this. So again, we've got a shape. Again, it's asking you to create a shape, a shape class. Again, that's going to be a parent class. It's going to have a single method called get area that's going to return the double type. So what I would do is go ahead and do those. Again, if I'm coding something like this up, reading these requirements, I would go ahead and start to create these classes right now. Again, when you create a new project in NetBeans, it gives you that sort of default main main method that's there. You can go ahead and start creating classes inside that project. So again, the way I would do it is, I would sort of go top down and just sort of start creating these classes as it asks you to do it, and deal with any errors that you're going to get or anything like that as you go. Fix any errors as you go. Don't just sort of write code and the IDE is going to tell you if you've got any errors there. So create the class, create any methods. In this case, it's asking you to create a get area method. Go ahead and create those things. It should return a double type. Go ahead and create those things as you go. And again, the sort of final step toward the end is going to be once you've got all the classes created, then you're going to go in the main method, start getting input from the user, and then pass that data over to the various methods, depending on what it's asking you to do. Okay. All right. So the next thing, so that's the shape class. Again, that's going to be our parent class. Now we're looking at our child classes. So the next thing it asks is create a class named circle that inherits from shape and contains the following constructors and methods. So again, you can see all the things that it's looking for there. Now it's just giving you the method names. It's not giving you any of the sort of guts of what the method is going to do, but again, that's up to you to write the code for it. And I think that there's examples of most of those things inside the chapter. So like the student in the student enemy would sort of look for references for that inside chapter 8, and then you use that that as a guide to write the class and also the methods. So same thing for square. It asks you to create a square class. Again, this is going to inherit from shape. And basically you've got the same set of methods for all these. And then it also asks you to do that for rectangle too. Now notice the arguments you're passing to each one of these is somewhat different. Circle and square, it's both singles, you know, they're both single arguments that's being passed to its circle. You're going to pass the radius to it. Square, you're going to pass the width. And then for rectangle, of course, you need the width, the height, and the width to be able to determine the area of a rectangle. So that's what you get there. And then it's giving you the formula for all these here. And then the only other thing it mentions is using the console class. Mirac likes to use that for the user input to validate the user input.
So the console class I've been having a difficult time wrapping
it's not easy. I went back and forth, and I just had, I mean, that's the convention that the book uses. So that's what I reinforce. I'm not crazy about it, but I mean, it sort of is what it is. I mean, as far as I don't know of a better way to do it as far as to be able to apply user validation or input validation to your program. So it's about as good as it gets as far as a sort of a quick, easy way to do it.
Okay. So we're running the main app and then pulling the user input and validation from the console class.
Yeah, and you're going to create that again. So you're going to create all of these classes in addition to adding the console class there. And then, so after creating these classes, the next step I would do is, okay, I would go and add a scanner object in, I would basically start to create this, this console output that you see here. Obviously, these are just going to be string messages here that are going to display on the screen. You'll use a scanner object to get the value from either C, S, or R from the user, whether you want to do a circle, square, or rectangle. And then, in this case, enter radius. So that radius versus something like width or height. So you're probably going to have a conditional statement of some sort. If it's C, then you're going to display this inner radius message. If it's R, you're going to have a separate set of code where you're going to ask the user to input the width and height. And then you're going to use the methods in the classes that you created to do the math and then return the value back so it can be displayed on the screen.
Okay.
And let's just look. I mean, I don't think it's going to hurt for you to have this up still. I mean, this is what the solution. So again, if you're inside here, this is what the sort of IDE is going to look like. You've got all of your classes over here. Shape is a very simple class, right? I mean, there's not anything really sophisticated about it at all. Really, again, all you've got is, again, since this is a parent class, they also ask it to be abstract. You're going to be using that abstract keyword.
That's something I'm not familiar with, that I don't remember.
So if you go back and look, yeah, I mean, it's sort of easy to miss, but abstract class basically means that it has to be an inherited class. You can't instantiate or create an object from this class. It can only be used to be inherited from.
Okay.
And that sort of makes sense in this case, right? You've got a class called shape, and then you've got these child classes, that are rectangle, circle, and square. You wouldn't want somebody to create a shape object because you can't really do anything with that. A shape has to be either a circle, square, in this case, circle, square, or rectangle. So that abstract keyword basically stops people from being able to instantiate it.
Okay.
And so then if we look at these, these are all circle, rectangle, and square, are basically all going to look the same, just they're going to have their respective attributes that are associated with them, right? So in this case, a rectangle has height and width. circle just has a radius, and then and a square also has or square just has width. Here's our console class again. Murat he gives that to you, so you can basically just paste that code in. And then let's see what the main method looks like. So again, here we're just going to display the title of the program. We're using our console.get string to get whether the user wants to create a circle, square, or rectangle. And here's our conditional statements. I talked about depending on what they choose, you've got to get different. You've either got to get radius, width, or height and width. So that's what this set of if-else statements does. After you get that data from the user, you're going to create a new shape object. So in this case, they're calling that C. And here we're getting the and then out here we're calling get name and then get area on each one of these. Now, okay, here, okay, I see what they're doing. So we've actually got two. So here we're assigning shape depending on what the user says they want, whether what they want to do a circle, square, or rectangle. We're assigning that to this shape variable. In this case, shape is either a circle, square, or rectangle. And then we're doing this shape.get class. And if we go, let's look at what that looks like. Yeah, I guess shape. Yeah, okay, that's an interesting way to do it. I'm assuming the book goes into detail about that more. I don't necessarily recall that, but this .get class in this case, since the child objects of a shape are either rectangle, square, or circle, that's what's going to get returned here on this get class method that's being called. We'll assign that to C, and then we can do this C.get name, and then C.get name, and then we can call the get area.
Okay.
Method.
And it's interesting that you it looks like the shape we're creating a shape variable from the shape up there at the top.
Yeah. Mm-hmm.
Okay.
And again, each object, rectangle, circle, or square, has their own get area method. It's going to be specific to them because the math is a little different for each one of those. But and again, the idea is here we're sort of reusing code. Again, but there's probably ways to make this a little more efficient than what it is, because you've got a fair amount of duplicated code. But again, each of these is sort of specific to the shape that's being called. So I think it's probably as efficient as it's going to get. What questions have you got? I mean, if it were me, if you want, I would try and tackle this. If you could spend some time trying to again start out just creating the classes for each one, and then work through the main method where you're actually getting the data from the user, passing it to the respective class based on the shape that the user wants to get the area of.
I think that's what I'll sit here and work through this one. I was trying to pick a project that we didn't go over. I went back and did one in 7, because 7 is where we started talking about classes. Mm-hmm. So I did a couple in 7, and then I got to this one, and I wasn't sure on how to go about it.
Okay.
But
and I can share. You want me to go, because I'll share the video of this. You want me to go ahead and share the solution with you, so you've got it?
Yeah, for sure. Okay. That way I can go back and look and see.
Yeah. And a lot of this, I mean, yeah, it'll be a good exercise for you to go through, and it'll certainly reinforce a lot of the concept. I'd go back and well, we've just covered, I don't know, it's been a couple of weeks since we did chapter 8, so you may want to go back again. What I would do is really use the book as a guide, and I'd have to look at what the book examples are, if they do anything, that's one of the things I like to do in general, is find something that's close in a sample program that's as close to sort of what the problem you're trying to solve is, and sort of use that as a guide. So that's sort of another strategy to take.
Perfect. That's what I'll do.
Okay, cool.
When I get confused and then I can't reason through the problem I'm trying to solve, then I just can't. And then I have a mental block.
Well, right. And it's good when you have those times, it's good to just walk away and come back to it. I have those times too. And then there's other times when you're not, I mean, you're just not, based on where you're at and the information you've got, you're probably not going to get through that problem without somebody either showing you a solution or, giving you a significant amount of help. And that's, I mean, that's normal. I mean, if you're going to go out there and be a consultant, work on your own, then you don't necessarily have that as a resource. But, in most jobs, you're going to be on a team, and they're going to be senior members of that team. And that's what those folks are there to help support you and help, when you have problems like that, they're going to sort of show you the way out. Because for most of us, once we go down a rabbit hole a certain way, it's difficult to sort of pull yourself back out. So,
well, that's good to know.
Yeah,
sometimes I feel like, because I'm hung up about my age and switching my road that I'm on at the age I'm on. So then I get to thinking, well, maybe I'm just too old to do this, but
I've had those, I was relatively old. I mean, I worked in technology, but I didn't start writing code. I was in my late 30s, and I went back to AB Tech and was taking all the programming classes they had there. And one of the first contract jobs I did was with Red Hat. And we had a guy there. There were a couple of us that were contractors, and we started the same day. And Ken Core was this guy's name, and I was in my late 30s. I might have been right at 40 years old then. And he was probably in his either late 50s or 60s. And I sort of watched him, and he's always been. I've always just, I've remembered his name over the years, but he was just very matter of fact about where he was at. And he had worked a bunch of technology jobs and did a bunch of other things in the past, but he was, he was probably in his late 50s or early 60s, I'd say. In fact, he had a cane. I don't know if he had an accident at the time or what, but he sort of walked with a cane. I remember the first day we were there, the hiring manager came down to get us, and we were going to take the stairs back up, and Ken's like, nah, I don't do stairs. He sort of showed us his cane. So we took the elevator up, but he was just very matter of fact, and you could tell. I mean, maybe I think age bothers us all just like anything does, but he didn't have a problem, and everybody else on the team was younger than we were, and we were having to learn from them. So I say that to say it's sort of an old adage that you've heard, but age really is just a number, and usually it's us that has a problem with our age more than other folks do. So, for what that's worth.
Well, that's good. I mean, I believe that we can do anything we want to do. If we're 80 years old and we want to get a PhD, then that's what we should do, if that makes us feel. I know there's a lady who she seems like she's about 70 years old. She's on my LinkedIn account. And she recently got her PhD. I think she got her PhD at 60 years old. And I just think that that's fantastic. And I just think that she's a really good person to mentor me and everything. Yeah.
Cool. All righty. I need to run.
Okay. Thank you. Yeah, I'm going to work through this. If you'll just share that, I'm going to wait